Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at the inverse of a function. By the end of this lesson, you should be able to explain what an inverse function is and when it exists. You should be able to find the inverse of a one-to-one function algebraically. You'll be able to verify that two functions are inverses using the notations. You should be able to state the domain and range of the inverse given the function. And finally, you should be able to solve equations of the form f of x equals c using the inverses. Here are some key vocabularies we'll be looking at. So I advise you pause at this moment and quickly take a glance before we begin our lesson. Without much ado, the advice to you is you get a notebook and your pen, and also try as much as possible to take notes and solve the questions before I try them with you. So let's start by first of all looking at what inverse do. If you have a function f, right? Now if the function f takes an input and produces an output, as you see over here, this is an input, and then it will produce what? An output through our function. Then what the inverse does is, what you got as your output, right? It will also give you back your input. So it just reverses the journey you have gone through. Okay. So if your function f of x leads you to what? Y, then all we are saying is the inverse of this function, right? If you put y in here, it will lead us to x. So it's like we saying you've been given a direction to a particular location. Now that you are at that location, the direction back to where you started your journey becomes the inverse. So that is what you see over here. To find the inverse of a function, there are 4 steps we'll be looking at, just 4 of them. So the first thing you need to do is to what? Given the function, rewrite the function as what? Y equals f of x, as you see over here. So you just equate your function to what? Y. Now if you're able to do that, you then swap the x and then y's. At this point, we just want to go through it. If we start solving the questions, we would actually apply them. So don't be bothered if you are not seeing any actual numbers and then substitution here. So let's just understand it. After equating our y to f of x, we then swap the x and then y. What it means is we replace every x with y and every y with x. You see, if you're able to do that, you then get a new equation you have to what? Solve. So you solve the new equation for y, and the answer you get now becomes your what? Inverse. That is all. If we start solving the questions, you would see. But one more thing we want to look at is the properties of inverse functions. Among the properties, the first one we'll be looking at is what? Composing a function with its inverse retains the input. So if you have your function f of x, then you are able to find the inverse of that function. Now, if you put the inverse of the function into the function itself, you get a value of x. The second one says the graph of the inverse is a reflection of the function in the line y equals x. With that, I would have to show you the diagram over here. So this line here, this middle line, is the line y equals x. Okay. Now, this particular line is our main function, and this becomes our inverse. Okay. Or you can call this the inverse, and then this is the main function. You realize that this line in here, what it does is it is a mirror Or you can say it is a mirror line which reflects every point on this one back to this. You see, so if these two lines are the inverses of each other, we see this, which is y equals x, being our mirror line. The next one also says the domain of the inverse function is the range of the function. Look at this over here. So for the function 2x plus 3, this is the range. That is the set of outputs from our domain. Now, if we find the inverse of the function, this now becomes the domain of the inverse. You see, so it is simply the domain of the inverse that is actually the range of the function. Then the last one says only a one-to-one function, that is a bijective function, that have inverses. If the function is many to one, it has no inverse. So with this little knowledge, let's actually see how we can apply in solving some questions. Now, as we always do, we'll be solving 5 questions in increasing difficulty. And I'll advise that for each and every question, pause, solve yourself before you come back and then look at my suggested solution. So for this first question, we are being asked to find the inverse of our function f of x equals what? 3x plus 7. So we would follow the steps. First of all, we know our function f of x to be equal to 3x plus 7. So step 1 says we should first of all equate our function to y. That is to say, let f of x be equal to y. We know what f of x is. That is 3x plus 7. So 3x plus 7 should be equal to y. Then the next step says we should swap the x and then y's. We should do what? Swap x and y. Swapping x and y simply means we have our 3. So instead of this x, I should put y, then plus 7. Instead of this y, I'm going to put x. So anywhere we see our x, we put y, and anywhere we see y, we put x. Then after this, what do? We solve for what? Y. Solving for y simply means you make y the subject. So making y the subject, we have 3y being equal to x minus 7. That is moving the 7 to the right hand side. And with that, we can choose to divide both sides by what? 3. So divided by 3, divided by 3. And then this 3 cancels out to this 3. So I'll be left with y being equal to an x minus 7 all over 3. This here is the inverse function. So we then say that therefore f inverse, that is the inverse of the function, is what? X minus 7 all over 3. So with regards to the properties we spoke about, I would represent this on the graph so that we actually see how the properties affect the function and then its inverse. So on our graph here is the line 3x plus 7. That is this blue one over here. Then let me plot this line as well, which is x minus 7 all over 3. Now this we have here is going to be the x, then minus 7 all over 3. Okay. Then the next thing we need to take note of is the mirror line. So for the mirror line, this is our mirror line. We said the mirror line is y equals x. So if y equals 1, x equals 1, y equals 2, x equals 2. This is the mirror line. So if I want to show all these 3, this is how it would look like. You see? So you see that the function and the inverse form an X, of which our mirror line is right in between. You see? So that will be it for the property we want to show. As we have seen, the function and then its inverse have what the line y equals x as their mirror line, where the function reflects perfectly onto the inverse. Let's take another question. So in our second question, it says we have to verify that f of x equals 3x plus 7 and f inverse of x equals x minus 7 all over 3 are truly inverses. Now, we know that from the properties, the graph of f inverse is a reflection of f in the line y equals x, and that is what we proved in our previous one. So this time around, let's use this for the proof. So we know that composing a function with its inverse retains the input. So let's try that and see. So let's say f of x is equal to 3x plus 7. And also f inverse of x is also equal to what? X minus 7 all over 3. So composing one into the other, we want f of f inverse of x. That is to say, wherever we see x, we'll put the whole of this inside. So that is going to be equal to 3 into bracket all of this, which is x minus 7 over 3, then plus 7. If we want to simplify, we know this 3 out here is multiplying. Okay, so with that, this 3 cancels out this 3. And in the bracket, we'll be left with an x minus 7 plus 7. And that gives us an x. Now we would have to test for f inverse of f as well. So for f inverse of f, it is going to be what? We know the f inverse is simply x minus 7 all over 3. So anywhere we see x, we are putting the function f in place of that. So instead of our x, which is our first term, we are going to put a 3x plus 7. All this here is our x. Then minus 7. That is it for the numerator. All over 3. Simplifying, we have 3x. 7 minus 7 gives us a 0. So we have 3x over 3. And we can simplify further to give us an x. Now, what have you realized? You realize that both the function and its inverse, when composed into each other, gives us what? X. It gives us the input. And that is what a property says. It says composing a function with its inverse retains the input. Hence our conclusion. Therefore, both composition retain x. The functions are confirmed inverse of each other. Very simple. Let's look at our third question. Our next question here says we should find the inverse of the function f of x equals 2x plus 5 all over 3. We want its inverse. So first of all, we're given f of x to be equal to 2x plus 5 then all over 3. So we need to let this be what? Y. So let f of x be equal to y. And that is to say, y is then equal to 2x plus 5 all over what? 3. After this, we swap. That is x for y and then y for x. Anywhere we see x, anywhere we see y, we are going to put what? An x. So x equals 2 times, instead of x, we are going to put the y, then plus 5 all over 3. Then we want to make y the subject. So making y the subject, we are going to cross multiply. We know there is 1 here. So x times 3 gives us a 3x. And then 1 times 2y gives us a 2y plus 5. Since that is y we want to make the subject, we are going to take 5 to the left hand side, giving us a 3x minus 5 equals a 2y. Dividing both sides by 2, we are going to get a y, which is then equal to a 3x minus 5 all over 2. This here is what we call the inverse. So we are going to say f inverse is simply 3x minus 5 all over 2. Now the next part of the question says we have to state the domain and the range. For this particular function, there is no value that can make it undefined. So the domain is simply all elements in R. You see. Then it also says we should find the range. Now we know the domain of this function, that is the f of x. So the domain of f of x is the range of f inverse. And the domain of f inverse is also the range of f of x. There is nothing that makes this undefined. There is nothing that makes this as well undefined. So their domains and ranges are both R. So we can therefore conclude that what? Therefore, the inverse of the function is 3x minus 5 over 2. Then both the function and its inverse have a range of R and then a domain of R. As simple as that. Looking at our last but one question, it says f of x equals 2x minus 9. That is our f of x, giving us 2x minus 9. And it says you have to use the inverse function to solve for f of x equals 15. Using simple algebra, I can just equate this to 15 and solve. But the instruction here says we have to use the inverse. So we have to find the inverse first of all. To find the inverse, we let y be equal to f of x. And if y is equal to f of x, it simply implies that our y is equal to 2x minus 9. After this step, we swap. So x is equal to 2y minus 9. That is swapping x for y. Then we now make y the subject. So we have x plus 9 being equal to a 2y. That is negative 9 moved to the other side to give us a positive 9. With this, we are going to divide both sides by 2. So dividing by 2 and dividing by 2, this cancels out this, and we have our y being equal to an x plus 9 all over 2. You see. So with this, we can now come here and then solve for what gives us 15. So we can say to solve for f of x, which gives us the 15, we can simply do that by using the inverse. And we know the x value is simply the inverse of what? 15. So our x is equal to f inverse. That is f inverse when we put 15 inside. Is going to be a 15 plus 9 all over 2. You see, we have our x, which is equal to 15 plus 9 gives us a 24. We have 24 all over what? 2. Hence our x is what? A 12. Now after this, you can choose to what? Verify. So verifying here simply means let's find f of 12. That is, we are putting x in place of its original function. And that is going to be a 2 into bracket 12 minus 9. This here gives us a 24. So we have 24 minus 9. And 24 minus 9 gives us a 15. That confirms it. So we can conclude by saying, therefore, x is equal to what? 12. That is all. Let's now solve our last question for this session. So our last question here says, f of x is simply x plus 3 all over x minus 1. And what are we supposed to do? We have to find the inverse function. We have to state the domain and then show that f is self-inverse. So first of all, let's find the inverse. We have our f of x being equal to an x plus 3 all over x minus 1. So we have to let f of x be equal to y. And if that is the case, it implies that our y is equal to x plus 3 all over x minus 1. This is the first step. The second step says let's swap x for y. So if you see y, we are going to put an x. So x equals, if you see x, we are going to put an y, sorry, a y. So y, then plus 3 all over, if you see an x, we put a y, then minus 1. With this, we know this x can be written as over 1. So we cross multiply. Cross multiplying, we get x times y minus 1 is equal to 1 times y plus 3, which remains as this. It is y we want to make the subject, so we'd have to open this bracket so that x times y then gives us an x y, then x times negative 1 gives us a negative x, and that is equal to a y plus 3. So grouping like terms, we have x, y, then this y moves to the other side to give us a minus y equals a 3. This x also moves to the right hand side to give us a plus x. We can factorize the y we have here so that we have a y into bracket an x minus 1, which is equal to 3 plus x. We then divide both sides by x minus 1. So dividing both sides by x minus 1, we have all of this over x minus 1, in which case x minus 1 here cancels out this x minus 1. So they are left with y equals a 3 plus x all over x minus 1. Or better still, we can write it as x plus 3 all over x minus 1. We have been able to find the inverse of the function. So that is x plus 3 over x minus 1. The second part says we have to state its domain. Its domain, that is the set of values that doesn't make the function undefined. You see? So for its largest domain, and this being a fraction, then it simply implies that x minus 1 should not be equal to what? 0. Because if it is 0, we would have an undefined term. Making x the subject, it simply means x should not be equal to what? 1. Because immediately x becomes 1, we are going to get 1 minus 1, which is what? 0 over here. Now, if you look at the function, it says we should show that f is a self-inverse. Look at the function f of x. Look at the value it gives us. Now, let's compare that to what we have over here. We are comparing this function, that is f of x equals x plus 3 all over x minus 1. And then look at the inverse we're able to solve. X plus 3, x minus 1. What do you see? They're actually the same thing. So this is what we say, the function is a self-inverse. The function is a self-inverse. We've been able to find the inverse of the function. We've stated the domain. And then this here shows that our function is a self-inverse. So our conclusion, we're going to say, therefore, f inverse equals f, which is also equal to x plus 3 all over x minus 1. F is a self-inverse, and it simply implies that if we are to operate twice on it, we are just going to get the input again. This is where we end this lesson, but as usual, I'll leave you with some exercises so you try on your own to test your understanding. So here are 5 questions for you just to test your understanding. If there's any issue of concern, you can always let me know in the comment section, and when notified, I'll address that for you. This is Hub Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.